Good morning together. Just trying to look out how many people already were in the tutorial yesterday, so there's some repetition for you guys. Trying to start with introducing myself. These are the dates I started working actively on open source and free software. It's not the usage time, but the real development time. So I'm close to 20 years now, 20 years of really writing my own free software in different areas. I've done Linux kernel, I'm still a Debian developer, and of course Postgres, which is what we're here to talk about. To give you another idea about my business background, I got into open source when working on my PhD, which actually is in database science, so it comes quite natural to get into Postgres. Then worked as a project manager and a branch manager, both in areas with database usage and database programming, and then became president of the Creditive group. Well, actually, when we started, it was one company. It's the company that runs the open source support center. You can see here what we do. We call almost everything support. I don't want to go into a sales pitch here, so if you have additional questions about that, ask me later. One other short slide for the introduction. The company was founded in 1999, and as you can see, we were able to move into different countries. We have an office in the States for more than 2 years now, almost 2 years now. Actually, it was started in October, so it's time to have an anniversary. And we're still growing in different areas. So now to the real topic of the presentation. Before I go into the details, if somebody comes up with a question, feel free to interrupt me. I don't mind getting disrupted in my flow. It's easier than just getting back to the topic at the end of the presentation. So I take it most people around here in this room have some open source experience, either be it by using it yourself already or by thinking about migrating to open source. And I put some reasons together why going to open source makes sense. All of this, by the way, not just this slide, the rest of the whole presentation is reflecting on those 12 years of open source experience we have in Creditive and taken from a lot of real life projects and real life prospect situations or customer situations. So most people start going to open source because of this first point here, no license cost. Yeah, that's easy. But you will notice that other services are involved as well. So this is just a small piece of the puzzle. The other pieces are way more important. If you talk to people who moved to open source a while ago, most of them will tell you, yes, it's nice to save licenses, but the major advantage lies elsewhere. Like the open standards, for example. Did you know that we already have data formats that nobody can read anymore? There used to be some software, some older systems like the Amiga, that's not available anymore because the company went out of business. There's no documentation left how this format looks like. So everything you ever saved in that file is lost. No way you can read it again. This won't happen with open source because you have the source code. There are actually, at least in my country or all of Europe, there are laws that say you have to keep some data for like 40, 50 years or even longer. Well, I don't know how IT infrastructure will look like in 50 years. So if you don't have open formats, open standards, and open source, how on earth do you make sure that you can read the data 50 years from now? I will talk more about high quality and these aspects later on. One other thing that comes up very often is this tailor-made standard software. Probably every one of you has worked with standard software and with custom programming or customly programmed software for yourself. And both sides have an advantage. It's nice to have standard software. You don't have to worry about updates and other things yourself. The software vendor will do. But standard software doesn't really fit your need. Was anyone ever part of an ERP system introduction and had to change the internal workflows completely just to fit the ERP system? So this is not exactly what you want to do, at least not on a regular basis. And the advantage that open source brings to you is it is standard software. There's a community working on it, but you are still free and able to help them, to work with them, to add stuff, to make it tailor-made for your needs. In general, software development, this is the classical waterfall model with requirements, design. I'm not sure you can read this picture over there. Requirements, design, implementation, verification, maintenance. I put 5 points out of this. The requirements are usually done by the guy or the group, the company who wants to use the software afterwards. Well, that's true for custom programming. It's not really true for standard software. Or did anyone ever get a chance to add their requirements to, like, Word? So in standard software, the concept phase is completely done by the software vendor. The implementation, of course, is done by the software vendor. Internal quality assurance is also done by the software vendor. The external quality assurance, that's you guys. Before you buy the software, before you accept the software from the vendor, you do your own quality assurance. And then the bug fixing. Yeah, well, if you paid people to program the software for you, you probably have them to fix the bugs because they want to get the money afterwards. So, let's say some of the proprietary software vendors have their own idea about bug fixing. I've been in situations where the software vendor literally told me, well, buy the maintenance and we will fix the bug. Well, but your software doesn't work. Well, I don't care. You didn't buy the maintenance, so we don't fix the bug. This is not what I would expect. I would expect warranty to tell me, well, they have to fix it. But sometimes they don't. Talking a little bit more about quality assurance. One of the big advantages that open source software has, and most people don't even recognize, open source software probably has the largest base of testers worldwide. No software vendor is able to pay so many people as a community has to test the software. Speaking of Postgres in particular, it's not just the project itself testing. There are a lot of people out there who test beta versions, who even test development versions against their own cases. So they are sure what to do. They know they can use the next version. There are always a lot of people out there. And the software developers themselves, the whole community, uses their own software. Getting away from a database because sometimes as a database community you don't have the real need for a big database. But just talk about like desktop software or email software. Without email software, probably the whole without open source software, the whole email infrastructure on the internet wouldn't be in existence. Almost all of it is open source. Due to the huge amount of testers, everyone using it with his own set of data, you get a huge amount of test cases. A lot of it will be redundant, of course. But they will find a lot of corner cases that even a professional quality assurance department might not even find. And you should be lucky if your software vendor has such a quality assurance department. Yeah, you're laughing, Robert. I talked to a software vendor. I didn't expect that. 50 software developers in their company. And I asked them about the QA department, and they said, no, we don't need any QA. The developers can test their code themselves. You want to buy that software? I don't. With open source, even you as the external tester, you get white box testing. You can look into the source code. You can see what's going on and why it doesn't work, or maybe your test case doesn't work. Maybe it's the fault, you're expecting something wrong. Whatever, you get the white box. The whole bug tracking is outside, open on the internet. There is no hiding of bugs. You will never see a situation where open source project, a community says, no, this is no bug for like 6 months, and then issue a service pack that says in the small print, well, we fixed that bug that they denied all the time. But you find that with proprietary software. And to me, personally to me, one of the biggest things is you can fix bugs and add features without side effects. I've been into a project, actually a database thing, when they used a not yet official feature of a big database. So this was supposed to be part of the next release, but it's already in there and working. And they really needed it for performance reasons. And then, just a couple of days before going live, they hit a limit, like 1,000 records, 1 million records in the index. I don't remember the details anymore. And didn't work anymore. So you call support, and they say, well, it's not officially supported. You have to upgrade first. So what do? With open source, you say, well, okay, let's backport the feature, because you don't want to upgrade your whole database system just a few days before going live. And another thought about usage of open source. This is an example that we did actually in 2003, the first one. People approached us and said, well, we need a huge system for all our mail users to scan for viruses, to mark spam, and all the stuff that's involved there. And we want it to be up all the time. Of course, the more nines we get, the better. We don't want to pay that much, of course. That's the usual situation. So we went in, we had some competitors going in with classical proprietary software, but we went in with a complete open source approach. This system now is up for 8 years with exactly a 0 downtime, the very first one we did. This is kind of the design with the internet going through firewalls, load balancer involved and everything. We've done more of those systems. The largest one we are running right now is designed to work with 17,000 emails per minute. And if you do the math, you will quickly recognize 17,000 means you need a lot of cluster nodes here to do all the virus scanning, because there's a lot of data. Of all those systems, on all those cluster systems, we have, at the customer side, we had one system that went down once, just because the customer thought it was a wise move to remove some of our configuration files while this cluster was running. Well, that doesn't work, of course. But all the other clusters have 0 downtime. It's possible. It's there. License cost exactly 0. Back then, in 2003, when we did it, the customer is to be considered an early adopter. Open source, well, I'm German. The German market in terms of open source usage is several years ahead of what I see in the States. But even that market, the system like this was pretty much an early adoption. It's completely, as I said, completely open source. We did all the work in it. Nowadays, we do the fixes, enhancement, and everything. And needless to say, customer is very happy with it. What then happened, as I said, email is more or less something that people are already used to as software being open source. Now, what then happened is lots of offerings higher in the stack came up, like classical groupware calendaring, whatever you add on top of it. It's not just email transferring, it's email server, it's email clients, whatever. And I don't think you would nowadays call anyone an early adopter who uses open source on email systems. A lot of stuff came up. As I said, free and open source software moved up the stack until we actually hit the top where the software really faces the user. And then other business critical usages came up. People said, well, it works for email. Why shouldn't it work for monitoring? A lot of web shops out there are essentially open source. Well, what about the database? Well, yeah, it's the most critical piece. A lot of companies still think, let's keep the database in the proprietary system because they don't trust open source enough to go open source with the database. However, as I said, customer-facing systems. Webshop was an example, but other examples, almost every web page you find will be run to some extent by open source software, be it the programming language, be it the web server itself, the middleware. Well, and nowadays, slowly, we get to the database area. Now you can say, well, MySQL was used quite frequently already. True, but MySQL never was a community project. So it's open source, it's GPL, yes, but it's a different scenario than going to Postgres. Because with MySQL, you were always able to buy a license to get this into the same legal situation as you were in when using like Oracle or Informix or MS SQL. With Postgres, you're not in that situation. You have to go to a third-party vendor. There are great vendors available that support it, that enhance it, do all the work around it, but it's not that one company really owns Postgres. So it's a slightly different situation. But again, what we see is that open source software is now moving down the stack again. So you really get the full cycle. It started in an infrastructure area, went up to the customer-facing systems, and then on the database side, it goes down again until we are at the bottom, which is more or less than Postgres. So I'm afraid this might be difficult to read, right? You don't get the names in it. This is a picture taken from Wikipedia giving you the history, the database development history. This one up here is Ingress. And as you can see here, it goes down to, this is Sybase, this is Microsoft SQL Server that was taken from an older Sybase version. And this is Postgres, which not really takes source code from Ingress. I've got more about Postgres in the next slide. And this yellow one here is Informix, which, due to Illustra, gets back to Ingress there as well, and then gets a connection to IBM DB2 here. This, by the way, is Oracle. Why do I have this slide in the presentation? It shows you that the project itself, the database software, is already pretty old and pretty mature. Yes, Ingress is not the same source code, just the same person running the show. But he was actually, Professor Stonebraker, he was actually the first one to do anything in relational database. This is, again, the history of Postgres. You probably have heard about that before, maybe even today. So it's Ingress, it's Postgres. Both have their proprietary spin-offs. The only difference between some of the Ingress spin-offs and the Postgres spin-off is that Informix did a wise move and also brought in Professor Stonebraker, not just got the source code from Illustra, but also got him in to do some development. So essentially, what Informix is nowadays, well, I haven't seen the source code, but I could guess that a lot of the things that Informix is nowadays are taken from Postgres. And then Postgres 95, Postgres SQL. There's a lot of development going on the PostgreSQL side, as you can see here. That's 15 years. I happened to field an email just the other day of a person who was asked to, well, you're looking into database, now Postgres 9.1 has come out. Don't you think it makes sense to have a look at it? And he replied and said, well, yeah, we did some performance tests a while ago, and Postgres was way too slow. And the interesting part is he didn't say Postgres was way too slow, but he said Postgres 95 was way too slow. So, well, I'm not sure. Maybe they did the test 15 years ago. And yes, there's a huge difference between Postgres 95 and PostgreSQL in 9.1. Performance-wise, I don't want to see the numbers. That's several orders of magnitude. General idea about Postgres development, again, I think you heard more or less how Postgres project is organized, with a core team steering it, and developer conferences, and developer meeting on conference like this one, and so on. To-dos are open. It's a classic community project. Started out with a handful of people, and more people came in. Actually, there's a picture from one of the developer meetings, and I guess I'm somewhere here. So don't expect to see me on if it's that small. I went to that slide just to go back to the original slide I had about software development in general. So there are the 5 points again: concept, implementation, QA internal, QA external, and bug fixing. How is this handled in Postgres? The concept is not just done by the developers, which would mean the software vendor again, if you have this analogy done in there. But concepts are also done by the users. If you need a feature, throw it in. If you're willing to spend some resources on it, fine. We will accept patches, no doubt about it. Same for the implementation. That's the patch part of it. If you really want to have a feature, implement it, and we will put it in. That is, if the development is right, if the source code is good enough, if it doesn't create side effects, and so on. But if it fits in there, we will certainly accept it. The internal quality assurance is done with project resources. There are a lot of people dedicating systems to do regression to build the build farm. So the whole source code, the whole Postgres source code is compiled automatically on a lot of different systems every hour, 2 hours, depending on the system. And all the regression tests that are part of the Postgres source code are run on those build farm members. So yes, it's easy, and I'm speaking out of my own history here, to commit a patch to our Git archive that, for example, misses a file. And you see the whole build farm becoming red very, very fast. But that way, we easily see problems in the development process. And then external quality assurance, as I said, with all open source projects. There are a lot of beta testers out there. We all run our Postgres, the developers. But there's a way larger community that doesn't do development, but also does testing, using of beta versions, and so on, and reports their findings. New features are tested over and over again at a pretty high speed. And bug fixing, yes, bug handling is completely open. There's a mailing list there. You send a bug to it. It's archived on the internet. You see the replies. You can see everything you need. So if you hear about a bug in Postgres, you can just check it on the internet. Is this bug still open for the version I have? Is it closed? What happened? Which patch fixes it? There's no hiding involved. In terms of database features, just a second. Oh, sorry about that. In terms of database features, I tried to find a way to compare databases without really comparing it, because if you run a real database comparison with proprietary products, you might run into license problems. So I went for a feature list, actually on Wikipedia again, that has several features that a relational database management system should have, divided in tables, views, indexes, capabilities, other objects, and partitioning. Of those, the first number on the second column is how many features Postgres has of those listed on Wikipedia, and the second number is how many features are listed. So there are actually 2 features missing here, but they are missing almost everywhere. Oracle doesn't have it, DB2 doesn't have it, almost nobody has it. This lacks parallel queries. Yeah, parallel queries are nice, but usually for your online system you don't need it. That's more of a data warehousing kind of thing. The only thing that's really missing is up here, it's materialized views. But you can emulate that quite easily. And the topic materialized views comes up again and again and again, but so far nobody really took the effort to implement it, because it's easy to emulate. Or in other words, there's actually, from the technical perspective, there's no reason to not go to Postgres instead of one of the other database systems. Everything's here. Performance-wise, again, you're not allowed to publish performance numbers for most other proprietary databases. But even years ago, I think it was in 2004, 5, 6, I don't remember anymore, one company did do a lot of performance tests and published those. And they just said database system 1, database system 2, and compared that to Postgres. And they found out that Postgres was very, very comparable to those other systems. You might still find the sheets on the internet if you Google for it. As far as I know, database 1 is Oracle, but I'm not sure. Again, the situation is Postgres really scales well. Postgres has good performance values. There's no real technical reason for not doing Postgres. And now, if you're in the situation that you want to move to Postgres, there's even help for that available. We have a compatibility layer for Informix and for Oracle. They are in different areas, but part of it can be moved. So there are a lot of stuff that those 2 databases bring with them that we also have implemented in Postgres, for Postgres, that you can simply use your own, your old source code, be it SQL programming, be it on the client interface side. It just works with Postgres. There are tools available to migrate stored procedures. Some of them are open, some of them aren't. Some of them need manual intervention, but at least there's something available that you can use as a first step. Database comparison, there are actually several tools available to compare databases. But again, you probably need to do some manual work in there and decide, well, how much precision do I need? For example, if you have a timestamp that you convert, that you migrate from one database to the other. It might be that one database just goes down to the second, while the other goes to tenths, 100th, or whatever of a second. And this doesn't really compare because the numbers are different. So you have to adapt the comparison tool to make sure those are listed as the same. But in the end, a tool like that can give you a report that says, yes, your data has been migrated, and yes, it's identical on both sides, which is actually what I would like to see after doing a migration. I want to have a proof that my data is right. And there are other tools to ease migration. We talked about that briefly in the tutorial the other day. This is nothing that is very uncommon. It's not that a lot of people it's not that nobody ever tried migrating it. There were a lot of migration projects. You don't hear about these projects that much, especially if they work out. You might hear more about those projects that fail. Actually, as I told you the other day, the part in Postgres source that I'm responsible for is the embedded SQL preprocessor for C. And the usage has been declined steadily over the years until it came to a point when I thought, well, it seems nobody's using it. And then I went to several conferences and found out that a lot of companies are using it without ever me noticing it, just because it simply works. And this holds for so many areas, in open source in general, but especially in Postgres, that people are just using it and it works. Some counter-arguments you might run into. Well, actually, I've run into all those arguments. You need some Linux knowledge. Well, yeah, if you want to run your database on Linux, you should have some Linux knowledge. But it's not really, it doesn't have anything to do with a database. If you want to run your proprietary database on Linux, you should have some Linux knowledge as well. And if you want to run your Postgres on the same platform as the proprietary software runs on, yeah, sure, you should already have the knowledge for that platform. Where's the argument? Have to train on Postgres. Yeah, that's true. Definitely. If you want to have your database administrators administrate a Postgres now, and they used to do whatever database you had, sure, you should give them a chance to learn the details about Postgres. However, it's not that complicated. It's not that you're starting right from scratch. I've seen so many training sessions. If people come in that have a solid, really solid database background, be it on Oracle, Informix, doesn't matter. It's more like a matter of days to get them up to speed for Postgres. You don't even need a week of training for that. Now, if people come in and have no idea about databases, yes, you need more than a week. But the same holds if you have a proprietary database. If you bring somebody in who never administrated a database, he will run into the same problem, or she. Of course. No difference there. And if you upgrade one of your databases to a newer system, maybe even skip one version, you will run into the same training problem. Maybe the database is not that bad, but did you ever try to get somebody to use the latest Office version when they used to do it with a very old Office version? Well, you probably need more training for that than you might need for migrating the software. It's difficult to hire Postgres people, yes, true. But it's also difficult to hire good database people in general. And we would love to see more Postgres specialists out there. No doubt about it. Postgres is great, and we could use more people really using it. Enterprise-level support is needed. Right, but it's available. There are several companies, not just us, who offer enterprise-level support for Postgres. It's just not that the software is ours, but we have those developers. If you walk around here, you will find, I think, at least 3 or 4 companies who can do enterprise-level support for Postgres. Now, some of them are specialized in support like us. Some specialize in other areas. But there are enough companies out there that you get not locked into one vendor. If you go to one service company, let's say service instead of support. If you go to one service company and you're not satisfied with what this service company does, just go to the next. There's no way for us to lock you in. Unless you go to a product, there's no way. It's open source. The only way we can lock you into us is by doing a good job. Well, and then you probably don't mind because it's your decision to be locked in. It's not ours. And the last one, well, I've got to give you a story about that one too. A couple of years ago, I went into a meeting with a prospect who was interested in moving from Oracle to Postgres. So I expected that to be, well, 1 person, 2 persons talking to me, just learning more about Postgres. As it turned out, I came in and was in a fairly small room, but roughly the same amount of people in as we have now in the room. And So I told them a little bit about Postgres, and then found out, well, almost all of the people came from the database area and didn't want no piece of Postgres. So their boss wanted, because he was able to save money, but the technical guys didn't want it. And then one of these guys got the killer argument out. He said, well, I don't believe in community. So I said, why? Yeah, well, it's just a group of students. Once these guys start developing a social life, they are gone. Okay. So I said, well, I'm married. I've got 3 sons. Would you consider this a social life? Yes. Yeah, but I still work on Postgres. I still do community work. So what else shall I do? Well, he said, maybe, but I still don't believe it. So you're out of luck. If somebody doesn't want to believe, there's no way to prove him wrong. You might run into a similar situation at some point, but then you might run into the same problem with other software as well. Some people just want to keep their own stuff together and don't want to learn something new. Just a couple of examples without giving names. When I come down to the return of investment stuff, I won't give you names either, because most of those companies don't want you to know they use Postgres. This one here is interesting, multi-terabyte data warehouse. Nowadays, multi-terabyte sounds like, well, yeah, that's a normal database size. But this migration was done like 6-7 years ago. Postgres was already able to handle this workload and this data load, no problem at all. A lot of universities are migrating. Might has to do with some software vendor migrating their software, which actually a very, very common situation, that software vendors go in and say, well, we have to add the commercial aspects to our offering. So if we sell a software that needs a database and the competitor sells another software, customer might at some point decide on price. And if we need the expensive database, especially if you have a lot of servers involved, there's a difference. So several software developers just in recent months decided, well, let's go with Postgres, at least as an alternative, because there's a major advantage. We can offer our product way cheaper. And so far, I've yet to see customers saying, well, I want to pay more for the more expensive database. All they need is to have somebody who is responsible for the database, who takes care of it, and makes sure they get their support. Some basic rules about how should you migrate. These are not special for database migrations. These are more or less about migrations in general, not even special for open source. If you want to do whatever migration it is, and even if you just move the office building to a new one, you should more or less comply with those rules. If you don't have a capital manager, a manager who knows what he does, the project is set to fail anyway. So this is more or less a standard set of rules. As I already wrote on this one the other day, this is the one I prefer most on those rules. Never go to, I'm going to tell it again. Never go for some temporary solutions. And the example I always use is my wife and I, we moved into an apartment, well, I think in '92. First people to rent in there and live there. And they had a problem with a fan in the bathroom. So they came in, fixed it, went out again. The next day it didn't work again. So we called them and they came in again just to find out that the spring in there was broken. The spring they replaced just the other day. Because they replaced it, they said, well, we don't have another one with us. We were sure that this isn't the problem. And they took one out of a pen, put it in there and said, well, this should work at least for a couple of days and we come back and put the real one in. Needless to say, I never saw these guys again. And when we moved out, it was still working. So the moral of the story is, if you add a temporal solution, it might work out well, but you get stuck to it. There's a good chance you never get away from this temporary solution. And if you do a migration, you don't want to create temporary solutions. You want to have the whole picture. And the other one that used to be very important, but nowadays most people really understand it. Essential parts have to be redundant. I don't remember how many times I talked to people that said, well, yeah, we have a database server. Okay, what do you do if this server falls down? Well, we have a good support. Yeah, right, but the database is down. Well, haven't thought about that. Fortunately, this doesn't happen anymore. People usually know that they have to have redundant systems. So finally, 3 return of investment cases. I'll give you some details about those cases. This was a small more or less small company, but they had all their data in a Sybase database and ran into some performance problems. So they brought, back then, personally me in to do a day of consulting that's listed there and go through those performance problems with them and try it out with Postgres. As it turned out, with this special version they were using, the Postgres optimizer could handle the problem that the Sybase optimizer back then couldn't handle. So they said, oh, that's great. We don't have to worry about upgrading Sybase, if that was possible, or even changing our database design, changing the application. We just migrate the database. Now you have to know the IT guy was just one guy, really loved Postgres. He wanted to go there anyway. And he could do all the migration work and stuff himself. They used middleware that supported Postgres. So all of their programming was against the middleware. And the middleware could simply switch to Postgres. The SQL code was standard. The data type was standard. Everything was standard, except for one minor thing. So all in all, take away the time it took to really unload the old database, to load the new database. The whole migration project in terms of external work was 1 hour. So as you might imagine, this is an instant return of investment because the investment is very small and you save quite some money afterwards. It's fine. If I was sitting on your side, I would say, okay, sounds good, but it's not a real life case. But really, I experienced this situation. But I'm pretty sure it's a rare situation. I've run into it once, and I probably will never run into the same situation again. This is another example of a company having 600 installations. Well, the numbers are from the real case, but kind of rounded up and down to get you simple calculation. The 600 is a real number. And they had 600 installations. It was kind of a warehousing system. And in all of their branches, they had one database server up and running. This is an Informix case, by the way. For whatever reason, they had $5,000 in license cost. And they wanted to keep their own self-developed software. So their idea was to build the software in a way that it runs against Informix as well as against Postgres. We just had to recompile it, of course. The upfront migration cost mostly is the development of the Informix compatibility layer on the client side, instead of changing their application. There were only minor changes to the application. They had to rename one variable and stuff like that. So very, very easy. They decided to only roll out the Postgres databases when they had to roll out new software anyway. So they didn't travel around, do all the rollouts at one time. But as soon as they have to go to a place, they just remove the Informix, put the Postgres in, migrate the data, and use the new version of their program. That comes up with roughly $2,000 for an additional cost per rollout. And they were able to do like 25 a month. Now if you do the math, you find out it just takes you 2 months after beginning of rollout to get to break even. Now this is slightly simplified because you just remove the whole license cost at the day you remove the database from your server. I know this is not true. It might take you a couple months before the year runs out and then you remove the number. But it gives you the idea of how this works. And then I got another one. Let me see, I'm pretty much in time. This was a fairly large project. We're talking about customer, some controlling machinery. They use a lot of database server. They have, as I said, 1,800 installations. And each one has 2 servers, an Oracle situation. So they have a lot, real lot of database servers. The price was fairly low. Large company, they got a good price from Oracle. And the migration cost was, in comparison, very, very high because they had to rewrite their whole application. They used some stuff internally that was very specific to their Oracle version and so on. So they had to rewrite almost everything. There was no database layer in the application. The database code was almost everywhere spread out over the source files and so on. The additional rollout cost was fairly low because they had some software distribution mechanism available. And that's why they were able to do a lot of rollouts per month. But even with this really high upfront cost here, it just takes them 8 months to recoup their investment. This is just because there's so much money involved. The database servers are so expensive that even a fairly, in comparison, high investment pays off very, very quickly. So all in all, and I think I exactly made it in my time slot, I removed the IM. Yes, it's possible. It's not just possible, it's desirable to move your database, especially your most important databases, to Postgres. There are a lot of advantages, and you can trust this open source software at least as much, if not more, than the proprietary software you have in use right now. And that's it for today. Questions? Okay? Then, thank you.